Alright, let's try another one. Here's my original function. I need to take its derivative. So we'll start over here, and again what I do is I pull off the easy parts, I guess. So here I have a portion for which the derivative looks to be negative and constant, right? The function's decreasing, it has negative slope, and that's decreasing at a constant rate, or the slope is constant. It's actually quite negative, so here's where I'm going to go. I guess as negative as I can go on my set of axes. Right here, between this time and that time, my function is flat. It's not changing at all. It's got zero slope. So I'm thinking that my derivative should look like that there. Between this time and that time, it's looking to me that my function it's decreasing, has a negative slope, and that slope is constant. So I'm thinking it's pretty far negative again, maybe not quite as steep as the original one, so I won't go quite as far down anymore. And then from here, look what happens to the slope. It starts shallowing out, right? It starts getting closer to zero. At this time right here, I think we're at zero slope. So when this thing transitions up, I'm thinking it has to connect up like so. Actually, let's think about what it's going to connect up to. I've got this piece right here, got a constant slope again. It's a positive slope. The function's increasing, but it's not nearly as steep as these other two. So I'm thinking that this thing should, its derivative should sort of flatten out right there, and this thing will come up and meet. So again, we'll go like this, and I'm thinking that this is a pretty good plot of derivative. All right, now it's time to integrate. So let's go up to this one. Once again, we will start off at x equals 0. So we're right there to begin with. Notice my derivative is positive, so therefore this function must be increasing, and I guess increasing at a pretty high clip there. So initially it's increasing, and as it goes out, the slope starts shallowing out a little bit, right? The slope gets smaller and smaller. Then right here, actually, the slope becomes constant and positive. So what that means is in this interval right here, we got a constant positive slope. So I'm thinking this thing sort of shallows out, and then boom, I have small constant positive slope. So this function is increasing here, but not very quickly. And then at this time right here, that's where derivative is 0, so that's where it goes from positive to negative. So we're going to reach a local maximum right there, kind of a shallow maximum. But right after that maximum, then we're going to come down pretty hard, or pretty steeply. So we'll turn around like so. Now once again, I kind of like to look at areas. Right here we've got some positive area, right? Here's a bunch of positive areas. So all throughout here, my function is increasing because I'm accumulating area. Now right after this point right here, right after this time, I'm starting accumulating negative area. And I'm thinking that this negative area will continue accumulating until maybe close to right around here someplace, maybe, where this negative area will exactly balance out this positive area. So if we say that this thing balances out about right here, this is the time at which our function needs to pass through 0. So going like this, actually at this time right here I get an inflection point, right? So all the way through this time right here, my slope is getting more negative, more negative, more negative. So steeper and steeper and steeper down, and then it starts turning back the other way, concave up, like so. But here's where I start getting this negative area, right? So it's going to keep on decreasing, keep on decreasing. It's going to get a little shallower, but keep on decreasing until we get here. So all throughout here, I've got negative derivative, so my function must be decreasing, right? Derivative's negative, function's decreasing. So it's decreasing all the way up until there. There's when my my derivative is 0. So it flattens out, and then it starts increasing again. So I'm thinking that this is my integral curve, right? Thing to check, whenever derivative is positive, function is increasing. Whenever derivative is negative, function is decreasing. When it goes positive again, that's when it starts increasing, right? So that's an important check on your solution.